Hello, everyone. Today I will present our machine learning pipeline for predicting medicine insurance costs use historical data. And our goal is to develop a robust regression model that accurately estimates insurance expenses based on the RILE's demographic and health-related factors. We begin by importing and preparing the training and test data sets. And the data includes uh, attributes such as age, BMI, smoking status, gender, region, and the number of children. And after loading those data sets, we ensured consistency in proposing for effective model training and evaluation. Here, the exploratory data analyze phase focused on understanding the data set structures, and we identified and handled missing value, checked for duplicate entries, and remove redundant rows. Outliers were examined using statistic technicals and value visualization tools to avoid model distortions. And the categorical variables such as gender and region were converted into numerical representations using encoding technicals. And here, uh, a correlation analysis was performed, allow us to identify the top three features most strongly related with the medical cost. For model selections and the training, we use HackerRad's automated machine learning capabilities. PyCharad streamlined our workflow by comparing multiple regression models efficiently. And through evaluation, we determined that GBR was the best performing model. And here's the reason, like medicine insurance cost depend on complex interactions between factors such as age, BMI, and smoking status, making it essential to use a model that can capture these nonlinear relationships. And GBR excels in this aspect by decision trees, allowing it to effectively model uh, intricate dependence in the data. And unlike linear regression, which assumes a linear relationship between features and the target variable, GBR dynamically adjust to complex patterns. Additionally, GBR outperforms random forest and single decision trees by achieving a better balance between bias and the variables, and though preventing underfitting and overfitting. Moreover, it focuses on important features, filtering out noise and improving overall prediction quality. After selecting GBR, we processed with final training and model optimization. The trained model was used to make predictions on unseen data, and performance was assessed using key regression metrics such as mean absolute error and R-squared score, and to visualize model performance and final potential overfitting. We generated learning curves which provide insights into how well our model generalized to new data. And we initially performed a missing value here. We already performed a missing find there is a missing value check and find that there were no missing value. Then we conducted a duplicate check and identified one duplicate row and which we subsequently removed. Finally, by compare the data shapes before and after the operation, we confirmed that the duplicate data had been successfully dropped. To improve the performance of random forest regressor, we use RFE to remove these important features and keep only the most relevant ones. This helps reduce noise in dataset, leading to better generalization. And we use hyperparameter tuning like number of trees, tree deeps to prevent outfitting, minimum samples need to be split a node, and the number of features considered for best split. Balanced bias and the variables by optimizing the deeps and the number of trees. Also, we ejected max deeps and minimum samples lift to avoid trees growing too deep and reduce complexity while mentioning productive power. And to assess and improve the fitting of the regressor, several technicals were employed in the whole process. Learning curve analysis was conducted to compare training and validation errors, helping to identify whether the model suffered from high bias or high variance. Cross validation was also used evaluate model consistency across different data subsets, reducing the risk of overfitting or data leakage. Error metrics such as RMSE and MAE were analyzed to measure production accuracy, ensuring the model effectively minimized the errors. And additionally, feature importance analysis was performed to use feature importance in random forest to determine which variable has the greatest impact on productions, allowing for further refinement of the model. And the residual plot analysis was also conducted to check for patterns in error, ensuring the residuals were randomly distributed, which indicated a well-fitting model. These steps ensured that the regressor were optimized for better generalization and improve predictive performance. Thank you.